Okay, so you know how sometimes you hear about people getting like 10 extra horsepower on the dyno just by switching to a different fuel injector?
Yeah.
That always kind of blew my mind.
Yeah.
But it really shows you how important those tiny components are in the grand scheme of
Oh,
things.
absolutely. It's
Yeah.
incredible how much of a difference those tiny droplets of fuel can make.
It really is well, welcome to Einstein Motors, where we break down all the complexities of automotive science.
You don't have to.
Exactly.
Yeah.
So today we're going deep on fuel injector.
We are diving deep.
Um, but before we get into the really technical stuff,
Yeah.
I think it's worth just taking a step back and reminding ourselves what a fuel injector actually does.
Sure.
I mean, we all know it sprays fuel, but why is that so important?
Well, you're right. It does spray fuel, but it's not just dumping it in there haphazardly.
Right.
The fuel injector is like a tiny little valve. It works with the ECU, the electronic control unit,
Right.
to meter the precise amount of fuel that the engine needs at any given moment.
Okay, so the ECU is like the brain deciding how much fuel we need, and the injector is the muscle actually making it happen.
Exactly. And the fuel injector doesn't just dump the fuel in either. It atomizes it, turns it into this fine mist
Right.
so that it can mix with the air more effectively.
Ah, so that's where those horsepower gains on the dyno come from.
Exactly. Better atomization means a more complete and efficient burn, and that translates directly into more power.
Now, I remember the days of carburetors,
Oh, yeah.
and let me tell you, those were not known for their precision.
Definitely not.
Was the switch to fuel injection like a major turning point?
Oh, absolutely. Massive improvement. Carburetors, you see, they were mechanical systems. They relied on things like air pressure and vacuum to draw fuel in it.
Oh.
Fuel injectors, on the other hand, are electronically controlled, so they can adjust the amount of fuel based on all sorts of data from sensors in the engine.
So it's like going from, estimating with your eyes to actually measuring things with a ruler. It's no wonder that fuel injection really revolutionized engine performance.
Yeah, it was a huge step forward.
But, I've heard there are different types of fuel injection
Oh,
systems.
yeah, there's a few.
Can you walk us through those and explain, why one might be better than the other?
Sure. So one of the earliest types of fuel injection is called throttle body injection, or TBI.
Okay.
And it uses just one or two injectors that are mounted right on the throttle body, and they spray fuel into the intake manifold.
Got it.
So it's kind of like a stepping stone between those old carburetors and the more modern systems we have now.
Right. So like dipping our toes into the electronic fuel control world.
Exactly.
Okay. So what came after TBI?
Well, then things progressed to multi-port fuel injection, or MPI.
Okay.
And with MPI, each cylinder gets its own dedicated fuel injector.
Oh, wow.
And those injectors spray fuel right into the intake port just above the intake valve.
Interesting.
So that allows for much more precise control over how much fuel each cylinder is getting.
Ah, so it's like giving each cylinder its own personal chef instead of just making one big pot of food for everyone.
Yeah, that's a great analogy. It means each cylinder can get exactly the amount of fuel it needs to operate at its best.
Very cool.
And of course, that leads to better performance and efficiency overall.
Okay, so MPI was a big step up from TBI.
Definitely.
But where did things go from there?
Well, as engineers kept pushing for even more efficiency and power, they eventually developed gasoline direct injection, or GDI.
GDI.
And this is where things get really interesting.
Okay, tell me more.
So instead of spraying fuel into the intake manifold, GDI injectors spray directly into the combustion chamber.
Wow, right into the heart of the action.
Exactly. And that allows for incredibly precise control over when and where the fuel ignites, which maximizes power and fuel economy and also helps reduce emissions.
So it's like going from, watering your lawn with a sprinkler to using a highly targeted drip irrigation system.
Perfect analogy. You're delivering the fuel exactly where it needs to be right at the moment it's needed.
That's incredible. But I thought there were like different types of GDI too.
You're right. There's wall-guided and spray-guided GDI.
Wall-guided versus spray-guided, huh? That sounds pretty technical. What's the difference?
Basically, it comes down to how the fuel mixes with the air. In wall-guided GDI, the injector sprays the fuel towards a specially shaped part of the cylinder head called the swirl cavity, and it's designed to create a swirling vortex of air.
Oh, so it's like creating a mini tornado in there to mix the fuel and air together.
Exactly. It helps ensure that the fuel and air are thoroughly mixed before they ignite.
Okay, that makes sense. What about spray-guided?
Spray-guided GDI uses a specially designed nozzle that sprays the fuel in a very precise pattern perpendicular to the cylinder head, and the shape of the spray and the way it interacts with the air is enough to ensure good mixing even without a swirl cavity.
So it's two different ways to achieve the same goal, a perfectly blended fuel-air mixture.
Exactly. And, each approach has its own pros and cons depending on the specific engine design and how it's implemented.
Wow, so it's getting pretty complex now.
It can be, but it's also fascinating when you start digging into the details.
Well, we've talked a lot about gasoline engines so far.
We have.
But what about diesel engines? I mean, they've had fuel injection for a lot longer, haven't they?
Yeah, they have.
Do they use these same systems?
They do use fuel injection, but they typically use a system called indirect injection, which is a bit different.
Indirect injection. Okay, I'm intrigued. What's the difference there?
So with indirect injection, instead of spraying the fuel directly into the combustion chamber, the fuel is injected into a pre-ignition chamber that's located outside the cylinder.
A pre-ignition chamber, huh? That's interesting. Why do they do that?
It helps create a smoother and quieter combustion process compared to direct injection in a diesel engine.
Oh, okay.
And it also allows for lower pressures in the main combustion chamber, which makes manufacturing simpler and less expensive.
Got it. So indirect injection in diesel engines is all about making things smoother, quieter, and more cost-effective.
Exactly. It's a good balance of performance and practicality.
Okay, that makes sense. Now, speaking of pushing the boundaries of efficiency,
Yeah.
I've heard about this really interesting engine design from Mazda called the SkyActiv X.
Oh, yeah.
It's supposed to combine the fuel efficiency of a diesel with the low emissions of a gasoline engine.
It is a really ambitious design.
It sounds amazing.
Yeah.
How do they pull that off?
Well, it uses a process called spark-controlled compression ignition, or SCCI.
This CCI, okay.
And basically, it lets the engine operate with a super lean fuel-air mixture like a diesel, but it still uses a spark plug to start the combustion process in a very controlled way.
Huh. So it's kind of a hybrid approach.
You could say that, and you want to know the best part.
I do, tell me.
It uses direct injection in a really clever way.
Okay, now you've got me on the edge of my seat.
Yeah.
Tell me more about this SkyActiv X engine and how it uses direct injection.
All right, so picture this. You've got the super lean fuel-air mixture, which is really key for getting that diesel-like fuel economy. But the thing is, burning such a lean mixture reliably requires incredible precision when it comes to fuel delivery and atomization.
Ah, I see where you're going with this.
Right, and that's where direct injection comes in.
Okay, so it's like trying to start a campfire with just a few twigs.
Yeah.
You really got to know what you're doing.
Exactly. With the SkyActiv X engine, the direct injection system ensures that the fuel is delivered to precisely the right spot at just the right moment for ignition.
Fascinating. So it's able to achieve this stable and efficient burn, even with very little fuel.
Precisely, and the results are really impressive. Mazda claims that the SkyActiv X engine can match the fuel economy of a diesel engine while still meeting strict emissions standards.
That's incredible. Sounds like they really cracked the code on efficient combustion.
They've certainly made some impressive strides in that direction.
And we talked a lot about the location of the fuel injector, like whether it's TBI, MPI, or GDI.
Right.
But are there other factors that can affect how well an injector performs? Like, do different designs or materials make a difference?
Oh, absolutely. The design of the injector nozzle, the materials it's made from, even the tiny manufacturing tolerances, can all have a significant impact on how well the injector atomizes the fuel and how accurately it delivers it.
So it's not just about where the fuel goes, but how it gets there. It's like the difference between using a garden hose and a high-pressure sprayer.
Exactly. And that's why you'll find different types of fuel injectors even within the same system category. For instance, there are high-performance injectors designed for racing or modified engines that can flow way more fuel and atomize it much more effectively than the standard injectors you'd find in a regular car.
Oh yeah, I've seen those high-performance injectors advertised. What makes them so special?
Well, they often have larger nozzle orifices to allow for a higher flow rate, and they might be made from different materials or have even tighter manufacturing tolerances just to make sure they can deliver fuel precisely and consistently even when the engine is running at high speeds and under heavy load.
So it's like upgrading from a basic kitchen faucet to a professional-grade sprayer. You can handle bigger jobs and finer details with ease.
Exactly. And you can definitely see the difference on the dyno. Upgrading to high-performance injectors, especially in a modified or tuned engine, can give you significant gains in horsepower and torque, especially at higher RPMs.
That makes sense. If you're pushing the engine harder, you need a fuel delivery system that can keep up.
For sure.
So we've covered the different types of injection systems and even touched on high-performance injectors. But I'm curious, what about the future of this technology? Where to go from here?
That's a great question. As we move towards more sustainable transportation and start exploring alternative fuels like hydrogen or synthetic fuels, fuel injection technology will need to adapt as well.
So we might see fuel injectors that can handle a whole new range of fuels.
Exactly. And these new fuels often have different combustion properties, so the injectors will need to be specifically designed to work with them and to optimize their performance and minimize emissions.
That's really cool. So what kind of innovations might we see?
We might see injectors with even finer atomization capabilities, or variable injection pressures, or even multiple injection events per combustion cycle.
Multiple injections per cycle. Wow, that sounds incredibly complex.
It is, but the potential benefits are huge. It would allow for even finer control over the combustion process, leading to further improvements in efficiency and emissions reduction.
So it's like having a chef who can add a pinch of spice at just the right moment to create a perfectly balanced flavor profile.
You got it. Instead of just one burst of fuel, we could have engines getting several carefully timed shots of fuel throughout the combustion cycle. It would be like a perfectly choreographed dance between fuel and air.
Wow, that's a fascinating image. It sounds like the future of fuel injection is going to be pretty wild.
I think it's safe to say that with the advancements in engine management systems and the push for cleaner and more efficient vehicles, we're going to see some really innovative fuel injection technologies in the years to come.
It's amazing to think that something as small as a fuel injector have such a big impact on the future of transportation.
I know, right? It just goes to show how important it is to understand the fundamental principles of how these components work and how we can optimize them to meet the challenges of a changing world.
Well, on that note, I think we've covered a lot of ground today, from the basic function of fuel injectors to the different types of systems, and even a glimpse into the future of this technology.
We have.
What are your final thoughts for our listeners?
Well, I hope that everyone listening now has a deeper appreciation for these tiny but mighty components that are so crucial to the performance of our vehicles.
Yeah, next time you hear that engine purr, take a moment to think about those fuel injectors working their magic.
Exactly. Whether you're driving a classic car with a simple TBI system or a cutting-edge sports car with the latest GDI technology, fuel injectors are the unsung heroes that make it all possible.
Well said. And on that note, we'll wrap up this deep dive into the world of fuel injectors.
But our exploration of the fascinating world of automotive technology continues. We'll be back next time with another intriguing topic, breaking down the complexities so you don't have to.
Until then, happy driving.
See you next time.